feedback amplifiers. What is an amplifier? An amplifier is an electronic circuit which increases the strength of the signal. An amplifier can be a voltage amplifier or current amplifier. What is the feedback? Why do we go for feedback? In order to increase the signal strength, in order to increase the gain of the amplifier, we go for feedback type. The feedback can be series and shunt. Here we are going to see about current amplifier. The current amplifier can be current series and current shunt feedback amplifier. So this is a current shunt feedback amplifier circuit, and the components which we are going to use: 1.5 kilo ohm, 5 kilo ohm, and we use DRB box, decade resistant box for 5 ohm and 500 ohm. So now we move on to the connection part. Here we need to connect two transistors. Keep the projected part to your side. Consider emitter, base, collector. Now can give the connection. So this emitter, base, collector. Same way we have to give another transistor. Similarly, emitter, base, collector. The emitter of the first transistor, we are going to ground. The emitter of the second transistor is connected to 50 ohm. So we connect the 50 ohm in the DRB box. So keep 50 ohm. So connected to the emitter, ground the negative part. Now connect 3 kilo ohm to the collector of first transistor. I have connected to 1.5 kilo ohm. Connect to the positive of the supply. To the row where you have connected the resistors, and ground the negative of the supply. Now we have to connect 500 ohm to the collector of second transistor. In the next DRB box, keep 500 ohm. Keep 500 ohm. Connect the positive to the collector of second transistor. and ground the negative of the DRB box. Connect another 1.5 kilo ohm to the base of the first transistor. Connect the function generator positive. This is a function generator. You can switch on the function generator. Function generator positive is given to the other end of the resistor. Ground the negative. As a feedback, 1.5 K from the emitter of the second transistor. It is given to base of the first transistor. So let me connect it to some other point. From the emitter of second transistor, connect it to a point. Take a connecting wire. Connect it to the other end of the resistor to the base of the first transistor. Now all the connections are over. Connect to the CRO positive. In order to find the output, in order to view the output, we connect positive of CRO to the collector of second transistor and ground the negative. Now we have to take the frequency response for various values of frequencies. We have to plot the values. Then we have to calculate the bandwidth of the frequency response of current amplifier. So let me take my values from 5 hertz. So from 5 hertz, keep 5 hertz in function generator. So I'm not able to get the output clearly. So let me increase my value of frequency to 10 hertz. Still more increase the value of frequency. To 15 hertz. So move it to 35. So take the darker value nearly point eight volt. Point 0.8 into 1. Now we have to increase the frequency value. Keep it as 100 hertz. The value reaches nearly 1, 2, 3, 4, 5, 6, 7, 7.4. So the values reaches to 7.4 for 100 hertz. We need to increase the frequency still more. Keep this as 1000 hertz. For 1000 hertz, the values remain the same. For 1000 hertz, values remain as 7.4. Still more, we have to increase the value of frequency. Till the value decreases. The value remains the same till 825 kilohertz. Till 825, value remains the same. If I still more increase the value, assume it as 1300 kilohertz. So nearly 1 megahertz. The value is decreased to 1, 2, 3, 4, 5, 6, 6.2. So gradually, if I increase the frequency, value reduces. See now, the frequency is 3116 kilohertz, nearly 3 megahertz. The value reduces to 2.2 volt. So we have to plot a graph. We have to convert the voltage value to dB value, and we have to plot for frequency versus voltage gain. My value increases, it stays constant, and then gradually decreases. So this is a frequency response for current amplifier. With the same circuit, we have to do for current series, get the frequency response, and then analyze the two circuits. This is a current amplifier. Thank you.